Good morning, students. I am Vetri Chelvi from Vetri and Vetri NEET Chemistry. Today, I am going to give the video, the lesson of P block elements. For your information, already I upload one video how to score 180 out of 180. There, the second weightage topic is P block. So, I am going to give video to the lesson of P block. Let us come to the question. For the properties mentioned, the correct trend for the different species is in the properties are here. We have to consider correct trend. Let us see one by one. The first option is given strength acid, Lewis acid in the trend boron, aluminium and gallium. For this, let us write the explanation. Boron, aluminium and gallium. Here it is everything as in the form of halides. They are asking the Lewis acid. How we have to approach the point is, first, what is the meaning of Lewis acid is acceptor of electron. Accept the electron pair is called it as a Lewis acid. So now let us see here the trend is. In the case of the boron, here it is the configuration is 2s2 2p1. Here in the aluminium it's become 3s2 3p1. Boron, aluminium, gallium, here it is 4s2 and here it is call it as a 4p1. So in the case of the boron, this is the central atom of your boron, where the p orbital is like that. Your chlorine is here, which is having the same 2p. Here the overlapping is with the boron of 2p with the chlorine. In the case of chlorine, it is what is the chlorine? Chlorine number is 17. So its configuration is ns2 np. What is it called as 5. Here it is 3s2 with 3p5. So in the chlorine it is 3p. In the boron it is 2p. So here the overlap takes place. What is happening is the electron here, the back bonding or the electron is not that much. So around the boron, the electron deficient is more. Whereas in the case of aluminium and as well as gallium, the overlapping of aluminium with the chlorine, gallium with the chlorine, the energy levels are close, so they are not that much electron deficient. So because in the boron, smaller size, more electron deficient, so it is the strong acid. We can call it as a Lewis acid. Compare this one. Now boron trichloride, and this is the correct option, first one. Let us go to the next one is inert pair effect, aluminium, gallium, indium. So before going to this inert pair effect, let me explain what is the trend in the group 13 is. What is group 13 is boron, aluminium, gallium, indium and thallium. Here the oxidation state is here +1 and +3 is the oxidation state in all the cases. Of course, here the thing is, here the lower elements are having this is the lower element, higher oxidation state, the group oxidation state, where the heavier elements are strong in them, its oxidation state is +1. So this is the condition of your oxidation state in the group 13. This is called as due to the inert pair effect. So now let us see what is the inert pair effect is. In the thallium, it is what is it called as here 2, 3, 4, 5, 6. So here you are writing 6s2 6p1. In the case of boron, it is what is it called 2s2 and 2p1. All the 3 electrons are available, so it is +3. Here only, here in this case only this electron is available, so it is stable with only +1 oxidation state. So inert pair effect is more in thallium. So in turn it is more in the what is called indium. Here the comparison is given aluminium, gallium, indium. Inert pair effect should be more in the indium. So this option is wrong. Now we are moving to the next question, oxidizing property. Here at the same explanation. In the case of aluminium, same aluminium, indium, thallium. Let us come and verify here. Aluminium, indium, thallium. So now aluminium is stable in the +3 oxidation state. That means it is not ready to come to the +1. So it is higher oxidation state. So it is acting as a reducing agent. So here aluminium is acting as a oxidizing agent. It is given. So it is also the wrong. Again repeating, aluminium plus 3 is stable, so it not ready to go to plus 1. So the plus 3 is not ready to plus 1 when it is acting as a reducing agent. So option is wrong. Now coming to the first ionization enthalpy, it is a very, very important, beautiful question. Now let us discuss this one here. Boron, aluminium, thallium. You again write boron, aluminium, thallium. So what is to be considered? What is comparing only I am taking. Top to bottom, what is happening is sizes increases. So what we are expecting is ionization energy should be decreases. What we are expecting is this is we are expecting, that is called this trend we are expecting, of course. So that is only of course given. Here what is the trick is, in the case of the, if I refer the data in the NCERT book with the what is it called ionization energy of aluminum and thallium, that trend is like this. What is this? This is expected and actual trend is thallium is more than the aluminium. So in the case of your thallium, the inner parapet is pronounced. So what is called as a, here nuclear charges, here thallium nuclear charge increases, so inward pull increases, so ionization inward pull increases, sizes decreases, so ionization energy is increases. So this is the trend. So aluminium to thallium, the ionization energy is, that is boron, aluminium, thallium, it is increases, here it is thallium. So small size shrinking due to inner parapet, poor shielding of 4f electron, so more energy is required. So this is the correct trend. You refer that data. So this is very important point we are expecting for the NEET question. So this question option also is the wrong. So the correct option is only the A. So this is very important question. Combining of 4 question it is given. Let us go to the next question. Remaining questions are very simple only. Now let us see here. The question is, boron cannot form which one of the following anion? Here you can verify boron with the fluorine, hydrogen, this thing. Here you can see the first case the coordination number is 6. Remaining part it is the 4. Here also 4. Here 2 into 2, 4. All the cases the covalency is only the 4. Whereas in the first case of your complex, the covalency of boron is given as the 6. In the boron, atomic number is 5. Write the electronic configuration 1s to 2s to 2p1, and the outer electronic configuration is 2s with 2p, s with the 2 electron, p with 1. On excitation, this is getting transferred. So you are getting, this is the unpaired electron available regarding your boron, and the orbital is you are having 1s orbital, 1s orbital and 3p orbital. So you are having only 4 vacant orbitals are available. So boron, the maximum covalency is only the 4. Whereas other element, what are the other elements is aluminium, gallium, indium and thallium, all are having valency is 6. With that we are completing the answer. So what is the answer is, your thing is this. Thank you children.